In section 7.4, you're going to be rewriting logarithmic expressions, and today I want you to be able to use the power and product properties of exponents to condense logarithms. So when you simplify logarithmic expressions, the goal is to turn the logarithmic expression into an exponent. Logarithms are exponents. So in order to simplify logarithms, they must have the same base. Now this is really important. I'm going to repeat that more than once. So here is the product property snipped from your book. And these can go both ways. You can condense them or you can spread them out. And if you are adding, you condense them by using multiplication. So I'll show you what I mean in the example down below. So we're going to use the product property of logarithms to simplify logarithms. So we're going to check first to make sure that the bases are the same. Now remember, the base is in the basement. It's the subscript. And then the second step is we're going to express as a single logarithm using the product property and simplify if possible. That means we want to change it to a number only, which is the exponent. Okay, so here's our first example. Very first thing, number 1 says to check to make sure your bases are the same. And again, the bases are in the basement. We have a 6 here and we have a 6 here. Then we pay attention to what sign is in between. It's a addition sign, so that means addition goes to multiplication when we write it as a single logarithm. So here we're going to write log base 6, and you always have to include the base. Log base 6, and then we multiply the two numbers that follow the base. So the 4 and the 9, that'll give us 36. Okay, so that's expressing it as a single log. We went from 2 logarithms to 1 logarithm. And now we need to simplify if possible. The way that you simplify this, since logarithms are exponents, you say, okay, my base is 6. What power do I have to raise that to equal 36? Well, 6 squared is 36, so your answer is 2. So your final answer, this whole expression, can be simplified to the number 2, and that's what you want to do. You want your final answer to be just a number, or the exponent. Okay, the second property that you're going to use today is the power property of logarithms. And since it says power, we're going to be working with an exponent. And this power property goes back and forth. Sometimes you'll want to put the exponent out in front of the logarithm. Sometimes it's in front of the logarithm and you want to bring it back up into the exponent. So just be aware that you can move it both ways. Now, just a reminder, if there's no base listed down here in the basement, we automatically know that it's a base of 10 if this says log. Okay, so using the power property of logarithms to simplify logs, what we're going to do, you use this when working with logarithms that have exponents. So just a lot of rewriting. I've told you all year that math is a lot about rewriting in order to simplify and solve. So now what we're going to do, we're going to move, this is the exponent, we're going to move it out front here. So that becomes 2 log base 2 of 32. Now previously we said that we could simplify this, and the way that I simplify that is this is my base. I say 2 to what power equals 32. And it's not 2 times what gives me 32. It's how many times you multiply 2 by itself to get 32. And that answer is 5. So this we can rewrite as 2 times 5. And I just noticed that I moved a 2 instead of a 6. All right, let's change this to a 6. Sorry about that. I was looking at the 2 as a base. So we're making this a 6. So that's going to make this a 6. So our final answer is going to be 30. 6 times 5 is 30. So this whole expression here changed to just the number 30. Okay, now we have a fraction that follows our base. So the first thing we're going to do here is bring out the 4. 4 log base 3 of 1/3 and now if I cover this up and I ask you what power do you raise 3 to get 3, you would tell me 1. And 1 would be the exponent. So if you remember from earlier in the year, whenever you take the reciprocal of a number, the exponent changes from a negative to a positive. So this would be positive 1, but when I take the reciprocal of this, it's going to become a negative 1. So this is going to equal 4 times negative 1. So that's going to equal negative 4. Okay, you have some questions to answer here and get checked.